What's up, Mindsetters? Welcome to it, your very first show of 2014. I'm just so excited, guys. I am Looney, and in studio with me is Natasha. Natasha, how are you doing?
Hi, I'm very well, Looney. Nice to see you in the new year and to be with these guys.
Yes, grade 10s, you are our fresh faces because last year you were in grade 9. So welcome to it, guys, your very first live show. Maths, we're doing maths today. Natasha, what's the topic for today?
Guys, today we're looking at algebraic expressions and we're going to be looking at products and factorizing.
All right, you heard it, grade 10s. I hope you're excited as I am. It's been such a long time. I haven't been here since like November, so we're still getting the hang of things, but we're so excited to have you guys tuning in. Remember to hit us up on Twitter and Facebook at Learn Extra, and our website is learn.mindset.co.za. So make sure you check us out, guys, for your notes and your videos on that website. So I won't waste any more of your time. I'll take it straight back to Natasha.
Thank you. Okay, guys, well, it's great to be back in the new year, and I hope that you're all ready to learn grade 10s. Welcome to the show. It's your first time here, and if you're in grade 11, I'm glad that you're already revising. So today, as I said, we're looking at algebraic expressions, we're looking at products and factors, and remember, guys, maths is all about building blocks. You need to set up this foundation now so that by the time you get to grade 12, this old stuff, the grade 10 stuff, that will seem so easy by the time you get there, but it's all important. So it might seem basic to you now, grade 11s, but remember, in grade 10, it was also a completely new section. So for you grade 10s who are seeing it the very, very first time, you've obviously done it a little bit at school. We hope that this year you're going to ace maths with us. All right, so we're looking at algebraic expressions, products and factors. And as I said, we're discussing both factorizing and products in this lesson. However, what I first want to show you, and I understand it's also in the notes, as Looney will tell you just now, the challenge question. So by the end of this lesson, you will all be able to do this question. But I want to see now, at the beginning of the lesson, how many of you can do this. So try this. It's on the website. It's on the notes as well. Have a look and see if you can factorize this rather scary-looking expression. But I promise by the end of the lesson, it's not going to look so scary. Try and factorize x squared times x minus 2 plus 7 times 2 minus x times x minus 10 times 2 minus x. I'd love to see if any of you can get the right answer to that. Let's get cracking with today's lesson. And guys, what I want to do is just remind you of a few terminologies that you have already come across. So most of you have been doing this at school already, so it might seem quite familiar to you. I hope so. But let's go over some of those terms. Firstly, we look at what is the meaning of a monomial. Monomial. Mono is the big clue there, okay? That is an algebraic expression with just one term. So mono, single. So for example, an expression like x or just 7. So just a single term. So x, 7, y, anything that's just a single term all by itself, we call that a monomial, all right? A binomial, bi should be your clue there. Bi, think of like a bicycle, 2 wheels. So an algebraic expression with 2 terms. That's what we call a binomial. So something like x plus y, all right, or a plus b, or a plus 7, and the list goes on and on and on. So an algebraic expression with just 2 terms is called a binomial. Guys, remember that terms, because I keep referring to terms, what are terms? When we're talking about terms, we are talking about algebraic expressions that are separated by plus or minus signs. Okay. A trinomial, that's an algebraic expression with 3 terms. So think of a tricycle, 3 wheels. Similarly, an algebraic expression has, with 3 terms, is called a trinomial. So if I look at something like x plus y plus z, that is an example of a trinomial. It's something that you've got to get very, very familiar with, because later on, and by the time you're completely done with factorizing, you're going to understand how to factorize trinomials. So it is something that you need to be very, very familiar with. It's a term you're going to use often through the rest of grade 10, and then certainly all the way up to grade 12. Okay. Let's get started with products. That's our first topic. And what I want to do is just remind you about a little something. Okay, so if I take, for example, something like 6, all right, I know, and yes, this does have something to do with products. So, for example, if I have 2 in brackets 3 is equal to 6, okay, then I can say that the factors of 6 are, what is it made up of? The 2 multiples. The factors of the 6 are 2 and 3. Okay, now very similarly, and that's why I'm bringing this up at this point, and we're going to go into factorizing in a lot more detail, but if you understand this basic concept, remember when you're talking about algebraic expressions and we start dealing with letters, it can become quite confusing. But if you just remember that the letters are just a placeholder for numbers. So if I've got X's and Y's and A's and B's, it's really just a placeholder for a number. So it all represents numbers. So if we take things back to explaining to how it relates to a number, it becomes a little bit easier to understand. So 2 times 3, those are the multiples of 6. Okay, sorry, those are the factors of 6. If we multiply 2 by 3, we get 6. So therefore, the factors of 6 are 2 and 3. All right, so the product 2 and 3 gives us 6. Distributive law works very similarly. So if I have P times in brackets A plus B, right? If I multiply that into the bracket, the P into the bracket by distribution, which you did in grade 9, you will get an answer of PA, so P times A will give me PA, and then P times B is PB. So therefore, what we can say is that if I'm looking at PA plus PB, that is equal to, backwards, P times A plus B. So following from our example of 2 times 3 is equal to 6, the factors of PA plus PB must be equal to P times A plus B. So that's the reverse, okay? All right, so we're going to get, as I said, we're going to get into factorizing a little bit later on, but this is something that you're already familiar with from grade 9, okay? All right, so remembering your distributive law, when you multiply, so you've got a variable outside, we multiply the variable outside by each term inside the bracket to give us our product. Okay, that's what we use the distributive law to do, to simplify. We're going to now use that to introduce the concept of multiplying a binomial by a binomial. Guys, we just introduced that concept. A binomial means 2 terms. Okay, so if you've just joined us, we're taking it nice and slow and easy and reminding you about all of these different terminologies. All right, binomial by binomial, it means we're multiplying 2 terms by 2 terms. Okay, the first way we can do this is by the distributive law. So, let's have a look. We had our 2 brackets, and I'll write it down for you again. 3x plus 2y times by x minus y. Now the one way we can simplify this, in other words get rid of the brackets, is by using the distributive law. So remember, everything in this first bracket needs to get multiplied by everything in the second bracket. Therefore I can set this up as follows. I can say 3x I multiply by the brackets. So I'm multiplying the first term in the first bracket by everything in the second bracket, both the terms. And then I multiply the second term in the first bracket by both terms in the second bracket. Okay, so I've split it up so that it's easier to see the distribution. We're basically multiplying the 3x by everything inside the bracket. All right. And then we're going to multiply the 2y by everything inside that bracket as well. All right, so just as you did before, distribution, 3x times x 3 times, remember whenever there's nothing written down, there's always a 1. So 3 times 1 is 3. And x times x is x squared. All right? 3x times negative 1y. So again, minus 1 times 3 is negative 3. X times y is just going to give me xy. Plus 2y times x is going to give me plus 2 times xy or yx. Remember, multiplication is commutative, so you can write it as xy or yx. It's the same thing. Plus 2 times negative 1 will give me negative 2. Y times y is y squared. All right. At this point, we're now going to collect like terms. So we look at what are the like terms here. We see there's 2 terms with xy's. So those 2 terms are obviously your like terms, so we're going to add them. So we end up with 3x squared, bring down the first term, minus 3xy plus 2xy is minus 1xy, and then we bring down the last term. Okay, so that's the one way, guys, that you can do products. When you multiply a binomial by a binomial, you can apply the distributive law. And remember, this works at any point. So say we were multiplying, as I'll show you a little bit later on, we were multiplying 3 terms by 2 terms, 4 terms by 3 terms. Whatever you're doing, the distributive law in terms of products will always, always work. So if you're slightly stuck and you're not sure where to turn and you can't remember the laws, you can go back to the distributive law and it will still work. Okay, but now that you're in grade 10, we want to teach you some new things. So we're going to look at FOIL. FOIL is a method that you can learn to multiply a binomial by a binomial. Now, very importantly, FOILing only works if you're dealing with 2 terms and 2 terms. It will not work for any other case. Okay, so let's have a look. We've got 3x plus 2y. That's my first binomial. And then we've got times by x minus y. So that's my second binomial. All right. So FOILing stands for, let's set this out here. FOIL stands for the order in which you will multiply those brackets out. So F means the first terms, then you multiply the outer terms, which are basically the 2 that are furthest from each other, and then we multiply the inner terms, and then we multiply the last terms. Okay, so if we apply that to our brackets, it says first multiply the first terms. So first term in the first bracket is 3x multiplied by the first term in the second bracket, which is x. You then multiply the outer terms. So that's the ones that are furthest from each other. So the 3x and the minus y. Those 2 are furthest from each other. Right? We're then going to multiply the inners, which are the 2 inner terms. So the 2y and the x. And then we multiply the last terms in each of the brackets. Okay, so that's the 2y and the minus y. All right, so that's going to just give you some sort of direction when you get a binomial and a binomial. This is what you do first, this is what you do second. But remember, you don't have to use this method if you find that you remember exactly, okay, I've got to multiply every term in the first bracket by every term in the second bracket, and you get to the same answer, then you can use that. You don't need to remember the FOIL method, but it just makes it really nice and easy and simple for you guys to follow along. It's also nice to have a set of rules that you can always work off. So what I always say is first get familiar with the FOILing method, and then later when you're an absolute star and you've perfected it, then you can go away from the method and do your own things, okay, as long as you keep doing the correct things and you get to the correct answers. All right, so I want to quickly finish off with this FOILing method, which is going to take us a few minutes before we go to an ad break. All right, so we've got first term by first term. 3x times x is going to give me 3x squared. Then we multiply 3x by minus y, and I get negative 3xy, right? Plus 2y times positive x is going to give me plus 2xy. And then plus 2y times negative y is going to give me negative 2y y squared. Again, guys, you do the same thing. You add your like terms. We bring down the first term and the last term. And we add minus 3xy plus 2xy will give me negative xy. All right. Okay, so now that you understand that concept of foiling, let's see you apply it to all of your examples where you're timesing a binomial by a binomial. Luni, I'm going to hand over to you.
All right. Okay. Mindset is we are going to take a quick break. Quick shout out to Daniel, Mandela, Maidemogelo, Bright, Tando, and Justice. Thank you so much for tuning in, guys. And great friends, remember, if you have any friends who want to SAP their matric, we do have SAP school. It starts at 9 o'clock in the morning and then it carries on after the live show. So make sure you tell your friends who are on matric, who want to SAP their matrics, who were matrics last year, that we do have SAP school for them. Okay, guys, we are going to take a break, so don't go anywhere. Welcome back, grade 10s. I hope you guys enjoyed the very first break of your very first live show, Learn Extra Live. Just to remind you guys, at the beginning of the show, Natasha did remind you that we have a challenge question. So it is on our Facebook page. If you just go to facebook.com/Learn Extra, you'll find the challenge question there. Quickly do it. It's just a factorization question. Do it and then you will be fine, and we'll go through it if you have time at the end of the show. So Natasha.
All right, guys, so we quickly revised products, and we're going to look at factors a little bit later on, but we're going to continue now with finding the products of certain binomials. All right, so this is question 1. We are asked to find the product of 2a squared minus b times 3a squared plus 2b. All right, so remember, you first identify it's a binomial by a binomial, therefore we can use FOIL. Remember, FOIL only works when you're multiplying a binomial by a binomial. All right, so to use your method, you multiply the first terms, then you go to the outer terms, then the inner terms, and then finally, whoopsie, that's in the wrong place, and then finally the last two. Okay, so these two. All right, so let's have a look and use that. 2a squared times 3a squared, 2 times 3 will give me 6. A squared times a squared will give me a to the power of 4. Okay, we then multiply, so that's the first one done. Then we're going to multiply the outers. 2a squared times positive 2b, 2 times 2 is going to give me 4. A squared times b will give me a squared b, right? Next we go to the inners, minus b times positive 3a squared. Remember here that a minus times a plus is a minus, so don't get your sign incorrect here. 3a squared times b will give me 3a squared b. And then minus b times positive 2b will give me negative 2b squared. All right? We then add our like terms and bring down the first term and the last term. So our common terms here, 4a squared b, positive 4a squared b, minus 3a squared b, and that will give me plus a squared b. Okay, hopefully those of you that are following along with the notes, you did get that answer. All right. The next one, we've got a quarter x minus half x minus half y times a half x plus a half y. We're going to do exactly the same thing, but I want you to pay attention to this example because we're going to come back to this type of example in a little while when we look at factorizing. Okay. So let's multiply. We've got a half x times a half x. That's going to give me, don't be afraid of fractions, a half times a half. When you multiply your fractions, you're going to simply multiply numerator by numerator. 1 times 1 is 1. And then denominator by denominator. 2 times 2 is 4. So I'm going to get a quarter x squared as the first term. And then we're going to multiply a half x times positive a half y. So a half times a half will give me a quarter and x y. All right. We then multiply the inners. A minus times a plus is a minus. A half times a half, just like we did there, is going to give me a quarter. And y times x is the same as xy. It's just going to be xy. Minus a half y times positive a half y. A minus times a plus is a negative. A half times a half is a quarter. And y times y is y squared. Now when we simplify this, we're going to get a quarter x squared. But look at what happens to the two middle terms. I've got a quarter xy minus a quarter xy. Those two terms are identical. So if we're saying a quarter xy minus a half xy, they're simply going to disappear because a quarter xy minus a quarter xy is just naught. And I'm just left with minus a quarter y squared, which I bring down. Okay, guys, so now let's look at this example. What do we have? How is it? I mean, the last time we multiplied a binomial by a binomial, we ended up with a trinomial. Now when we multiply a binomial by a binomial, we're ending up with just two terms. How is that possible? You guys, you have seen this, because you've done it at school so far. We know that if we've got exactly the same terms in both brackets, but one has got a minus sign and one's got a plus sign, this leads us to the concept of a difference of two squares. Okay, remember, for a difference of two squares to work, which we will do in factorizing, you need to have exactly the same terms in both brackets, one with the minus sign, one with the plus sign. That's how you identify a difference of two squares. Okay, all right, but when we're dealing with the product of that, so let's have a look at a similar example that's not in your notes, but I quickly want to show you. So if I have a minus b times a plus b. Okay, to find the product of this, if I've got a minus sign and then a plus sign, but exactly the same terms in each bracket, so I've got a, b, but one's got a minus and one's got a plus. All we've got to do in order to simplify that expression is we simply say a times a, we square the first term, and we square the last term. B times b is b squared, and we separate that with a minus sign. So a minus times a plus is a minus. And this will later lead us backwards to what we call the difference of two squares when we look at factorizing. But I just wanted to mention that now because we have seen it at this point. Okay, and a lot of you, I know, have already seen that at school. Okay. All right, so still carrying on with products, we are asked to find the product of 2a minus b squared. Don't be afraid of the square, because remember, all it means is you're multiplying the same thing by itself. So basically, 2a minus b squared is the same as saying 2a minus b times 2a minus b. It's the same thing multiplied by itself. It's like any square. If I have 7 squared, it's the same as saying 7 times 7. So it's the same when you're dealing with brackets. Don't get scared now because you see variables. It's exactly the same as before. So 2a minus b squared. To simplify this, you can write out your two brackets and then apply your rules for FOIL. Okay, so you can do that by using FOIL. But guys, what I want to show you is the rules for squaring a binomial. Okay, so the rules for squaring a binomial, the first thing you do is you square the first term. So we take 2a, we square that. The middle term is then the product of the two terms multiplied by 2. Now, if you take the product of the two terms, you know you're going to get a positive times a negative will give you a negative overall answer, right? We then find the product of those two terms, so 2a times b, and we multiply that by 2. Because basically what's going to happen is when you multiply out by FOIL, you will end up seeing that you end up with two middle terms that are exactly the same. You're going to end up with minus 2ab minus 2ab. Hence, this step that shortens everything when we square a binomial. See, we just went over to the next slide there because I got so excited. So, when you're multiplying a binomial, when you're squaring a binomial, you will end up with two middle terms that are exactly the same. So instead of going through the whole long process of FOIL, we want to be more efficient. So what we do is we come up and formulate this rule to make life simpler and to make maths go quicker. So we square the first term, and then the middle term is the product of the two terms, the product 2a times b, and we multiply that by 2 because there's going to be two sets of them. And then we square the last term. So obviously if you square negative, we're going to end up with a positive b squared. Simplifying this, 2a squared is going to give me 4a squared, right? Minus 2 times 2 is going to give me negative 4. A times b is ab, and we bring down the plus b squared. All right. If you were to FOIL this out, you will get exactly the same answers. But I just want to go over again, and maybe because you've got this in your notes, it will make sense now when you look at the example. The rules for squaring a binomial. The first thing you do is you square the first term. You saw that when we took the 2a and we squared that, right? Then we add the square of the last term. That's when we took the b and we squared that. And the middle term is the product of the two terms. We multiply that by 2 and either add or subtract depending on the sign. So as you saw in our brackets, we subtracted it because we had a positive number to deal with and a negative number to deal with. So we had to subtract the two terms. So this is what the last step is saying. Multiply the product of the two terms by 2. So we multiplied 2a and b by 2, and we subtracted it because the sign of the b was negative. Hopefully you guys all have that and you understand it and it's all clear in your mind. All right. All right, let's look at finding the product of a binomial and a trinomial. And this is what I said to you before. When you're dealing with a binomial and a trinomial, or a binomial and a polynomial which has 4 terms or more, all you're going to do is simply apply the distributive law. Okay, so here we asked to simplify 2x plus y times x squared minus 3xy plus 4y squared using the distributive law. I'm going to split this up into 2x times x squared minus 3xy plus 4y squared. And then it's going to be plus y times x squared minus 3xy plus 4y squared. All right. So just distributing into the bracket, 2x times x squared is going to give me 2x cubed. 2x times negative 3xy is going to give me negative 6x squared y. 2x times positive 4y squared will give us 8y cubed. Sorry, 8y squared. Not paying attention to my own working out. 8y squared times x. All right. Then we multiply the y into the same bracket. We end up with plus y times x squared. And then we're going to end up with minus 3xy squared. Remembering a minus times a plus is a negative. And then plus y times positive 4y squared will give me 4y cubed. All right. Okay, we then look at at our answer and see if there are any like terms. So we've got minus 6x squared y, that's the same as, which other term has x squared y? We see we've got this one. X squared y plus y x squared, there we go, so that's the same thing there. And we've got the same terms with the plus 8y squared x, that's that one, and the minus 3xy squared. Okay, so I've identified the same terms. I've got x squared y minus 6, and then I've got plus 1y x squared. All right, 2x cubed and the 4y cubed, those two are individual terms. They have no other terms that you can add them to, so you simply bring them down. Okay, minus 6x squared y plus yx squared will give me minus 5x squared y. And then plus 8 y squared x minus 3xy squared will give me plus 5y squared x. And then we bring down the plus 4y cubed. Okay, with this one, guys, you should just try to be a little bit more careful, because you can make lots and lots of mistakes when you're dealing with so many terms and you've got to add all the like terms together. What I'm going to do, because I do want to get onto the factorizing, is I'm going to leave part B for you guys to do by yourself. I want you to try this, and if I have time, I will come back to this one because this is a special one. But I want you guys to try this at home for yourself, and let's move on to the factorizing. All right. So here, just a reminder, a very quick reminder about factors. And remember, products and factorizing, those are inverse operations. So if you want to check if your answer to your factorizing is correct, you simply multiply your brackets out and you should get what you started with. So that's a way for you to check that your factorization is correct. All right? When we look at factorizing, we look at all the different types of factorizing, which I'm going to go through now. But the main thing, and guys, you've got to remember this. If you don't remember this, you will lose marks in your tests. Okay? You always start off your factorizing by looking for a highest common factor. HCF, highest common factor. You first take that highest common factor out, and then you see if any of the other things are possible. Okay, so the first thing is you always look for your highest common factor. Okay, grouping, that's where we group like terms together, and I will show you that when we do an example. Difference of two squares. So difference of two squares, if we have something like x squared minus y squared, and this ties into the products examples I showed you earlier, you simply, to factorize that, you take the square root of the first term, there we go, and then you add the square root of the second term, and then in the second bracket it's the square root of the first term minus the square root of the second term. So with difference of squares, you will always find that that middle term cancels. There's no term in xy here. So difference of two squares, how do you identify it? You've got two terms. Okay, so say we've got a squared minus 9. You've got two terms that are perfect squares, right? Because a squared is a times a, 9 is 3 times 3, and they always have to be separated by a minus sign. That's why we call it a difference. Don't make the mistake of confusing this with that. Okay, if it's got a plus sign, you cannot factorize that. Okay, a squared plus 9 will just stay like that. There's nothing that you guys can do with that at this stage. So a squared plus 9 is not a difference of squares. A squared minus 9 would be a difference of squares because we've got two perfect squares separated by a minus sign. In order to factorize that, we take the square root of the first term plus the square root of the second term. That's our one factor. The other factor is the square root of the first term minus the square root of the second term. All right. Now, difference of two cubes. Again, with this, there's a specific rule that you guys need to remember, and if you practice it enough, you will remember the rule. So if I've got x cubed minus y cubed, that is two perfect cubes. All right? The thing with a difference of two cubes, so we've got x cubed minus y cubed, right? We're going to factorize this, and it will factorize into a binomial times a trinomial always. Okay, so when you factorize difference of cubes, it's always going to factorize into a binomial times a trinomial. Okay? To factorize it, your first bracket is always the cube root of the first term. So the cube root of x cubed is x. And then you take your sign off your middle. So if it's a minus, you bring down the minus. The cube root of y cubed is y. Your second bracket is always the square of the first term. Your last term is the square of the second term. So minus y squared is positive y squared. And then the middle term, importantly, you'll notice a sign change. The middle term is the product of the two terms, but with the opposite sign. So instead of it being negative xy, you change the sign so it's positive xy. All right. Now remember when I said to you that you can only do a difference of two squares. So if you have x squared minus y squared, you can only use that rule for factorizing if there's a difference of two squares. When it comes to cubes, it's slightly different. You can either find the sum or the difference of two cubes. So similarly, as you saw the difference of two cubes, we do a similar thing to the sum of two cubes. Cube root of the first term in the first bracket plus the cube root of the second term. Then your second bracket, you square again. You square the first term. You square the second term. The middle term is the product of the two, but with the opposite sign. X times y, but not with the plus sign, with the negative sign. All right, trinomials we're going to get into showing you with practical examples how you can do trinomials. All right, Looney, are we good to carry on?
We need to take a break.
All right.
Yes. Mindset says we're going to take a break. Just more shout outs. Special shout out to Up here where he's now in grade 11. He was in grade 10 last year, but he says he's tuning in. And then quick shout outs to the people who are actually answering the challenge question. To Matlaatsi, Msimelelo, Homozo, and Spesihle. Thank you so much, guys, for answering the challenge question. Mindset says I urge more of you to answer that. It's a quick factorization question, so make sure you answer it. It is on our Facebook page. We'll see you straight after this break. Welcome back, Mindsetters. From that break, I won't say anything else. Take it straight back to Natasha.
Okay, we're on a roll, Looney.
Yes,
There's a lot to cover. All right, so guys, remember this is the first part of your algebraic expressions. We'll carry on with more next week when we look at algebraic fractions. But what I want you guys to do, and you will have this if you're following online, is to improve your skills. So we have a couple of questions that we set up under factorizing, and I'm going to do one or two of them, and I'd like you guys to try those that I don't cover, try those at home. All right. So the one that I'd like to have a look at is this one here, number D. All right, 4D. We've got 2x to the power of 4 minus 32. And it brings in nicely all of the rules that you've learned so far. The first thing we always do is we look for the highest common factor. So I've got 2x to the 4 minus 32. My highest common factor here is 2. So I pull that out. All right. Take 2 out. Remember, you divide each term by the number you've taken out. 2x to the power of 4 divided by 2 will give me x to the power of 4. And negative 32 divided by 2 will give me negative 16. Now if you look at within your bracket, can you go any further? So you don't stop there. You factorize, you take out your HCF, you then look at that and say, well, can I go any further? And yes, you can, because we now have a difference of 2 squares, or we call it dots, okay? So in order to factorize this, I take the square root of the first term. The square root of x to the power of 4 is x squared. Then I take the square root of the second term. The square root of 16 is 4. And we separate them. One's got a plus sign and one's got a minus sign. Okay, so the first bracket, x squared plus 4. Second bracket, x squared minus 4. You then have a look, and remember, you never just stop with factorizing. You have a look and say, well, can I go any further? And if you did ask that question, you would see that yes, you can, because x squared minus 4 is also a perfect square. So we can factorize that a little bit further. The square root of x squared is x, and the square root of 4 is 2. In one bracket, we're going to have a minus sign, and the other bracket, a plus sign. It makes sense, because a plus times a minus will give us that negative 4. Okay, so in this example you saw we had to first apply finding an HCF, and then difference of squares, we had to apply that twice in order to get to the final answer. I also want to look at something we touched on just before the break, which is the sum of 2 cubes, showing you that whereas difference of 2 squares only works with a difference, the sum of 2 cubes, as it says, implies you can factorize two cubes that have a plus sign between them. Your first step should always be to analyze what you're given and say, well, is there a common factor? And in this case, there's no common factor, so we can go straight into the factorizing. What you'll notice me doing is opening one little bracket and a bigger bracket. Because remember, whenever you factorize cubes, you're going to end up with a binomial times a trinomial. That will always happen. All right? So to factorize this, we take the cube root of 125y cubed. The cube root of 125 is 5. The cube root of y cubed is y. And then the cube root of 8 is 2. You don't have to then guess about the sign that goes in here, because it's simply going to be the sign that's in the middle. So we just bring down the plus sign. There's no guesswork there. Then your second bracket, you square the first term. So 5y squared will give me 25y squared. And your middle term is the product of the two terms with the opposite sign. So 2 times 5y will give me 10y, but with the opposite sign. So not with the plus sign. We're going to change that to a minus sign. And there are reasons for that, the technicalities in that, but basically what it means is that if you do that, when you multiply this bracket out term by term, you will get the original expression that you were given. So that's why this works. All right. And then your last term is going to be the square of the 2, which is just 4. Okay, so it's basically just remembering this rule that you have to cube root the first term, cube root the second term, carry the sign down. Then your second bracket with your trinomial is the square of the first term, the square of the second term, and then the middle term is the product of those two with a change in sign. And as I said, that change in sign is just because if you do change that sign, when you multiply everything out, it all works out nicely. So it's a nice rule that was formulated to make factorizing cubes easier. All right. Now, guys, what I really want to do is to get onto those challenge questions. And I've had a look at the Facebook page, and 1 or 2 of you are on the right track. So let's see if you got it. Okay. So this was our challenge question. And this involves a couple of things. It involved taking out a highest common factor, and it also involved factorizing a trinomial. So it's a nice one to combine everything you've learned so far. Now remember, a highest common factor doesn't have to be just a number or just a letter. It can be an entire bracket. Now if I look at the expression I've got here, I see that the brackets x minus 2, 2 minus x, and 2 minus x are very similar, but the signs are different. Okay, I'm going to show you a trick that we can use to make those brackets exactly the same. Think of if you have something like 5 minus 3, right? You guys know that that answer is 2. Okay, you all know that. However, if you had 3 minus 5, that would give you negative 2. If, however, I wanted these two to be equivalent, all I would need to do is to multiply the negative 2 by a negative 1, right? Because negative times negative will give me the positive 2. So in other words, to make the answers to these two expressions exactly the same, you simply have to change the sign in front of the bracket. Okay, then it becomes exactly the same expression. Okay, so you understand that 5 minus 3 will just give me 2. If I want to make these exactly the same, I simply change the sign in the front of the bracket. What that means, because remember, what you're literally doing is you're pulling a negative out of the bracket, okay? So how this is going to change that, so maybe it's slightly incorrect for me to put the minus there straight away, but putting the minus in front means you've got to swap your terms around. So it's the same as dividing by a negative. Positive 3 divided by negative 3 will give me negative 3, and then negative 5 divided by negative 1 will give me positive 5. So a negative times 5 minus 3 will give me exactly the same answer as 3 minus 5. All right. So having said that, if I want to make 2 minus x, x minus 2, so I want to change that bracket around to x minus 2, all I simply have to do is change the sign in front. So literally divide through by a negative. The same here. If I want to make 2 minus x the same as x minus 2, change the terms around and change the sign in front. Okay, so I'm going to get x squared times x minus 2 minus 7, because I've pulled that negative sign out. I've pulled out negative 1 if you want to think of it that way. I've pulled negative 1 out as a common factor. So I'm going to get minus 7 times x minus 2. And then I'm going to get plus 10, because once again I've done the same thing. I've taken negative 1 out as a common factor of that bracket, 2 minus x. Or if you just want to remember a rule, change your terms around and change the sign in front to give you an equivalent bracket. Okay. All right. So we've got x squared times x minus 2 minus 7, x minus 2 plus 10, x minus 2. As you can see, we've got this repeated common factor of x minus 2. So we've got an entire bracket as a common factor. So our highest common factor in this expression is going to be x minus 2. We literally pull that out of the equation and we're left with x squared minus 7x, and I'd forgotten to write your x down there, plus 10. Okay, you get to this point, but guys, remember what I said before, you're not done. Because now you look at this and you say, well, can I go any further? And yes, you can, because x squared minus 7x plus 10 is a trinomial that you guys have seen last year. So I can factorize that into x, and we've got 10, which is 5 and 2. So we get x minus 2, x minus 5, x minus 2. Because we've got that repeated bracket, we can write this as x minus 2 squared times x minus 5. All right. Okay, so hopefully, and I saw some of you were answering this, hopefully you got to that answer. X minus 2 squared times x minus 5. Looney, anyone?
I'm just trying to look. X minus 2.
X minus 2 squared times x minus 5. I think some of them came close, though.
Close, yeah.
And it is the first lesson back.
Yeah,
so
and they did it until a few steps, and then they missed the last step.
Okay.
Yes.
Well, it is the first lesson back, so obviously we'll give them a break. Okay?
Yes, we will. Okay, is that it for us?
Yeah, so guys, I hope that you all understand your products and factorizing thus far. If you have any questions, obviously let us know during the week and we'll try to get to them. And remember to test your skills and let us know how you're finding the show.
All right. Thank you so much, Mindsetters, for tuning in. Thank you to all our grade 10s, and I hope you guys are enjoying the show and you will enjoy the show for the rest of the year. Just a reminder, so many of you guys are asking what time are the grade 10 lessons. So grade 10s, for you, seeing as though you weren't here with us last year, all our grade 10 lessons start at 4 o'clock. Okay, so Monday we have maths, Tuesday we have physical sciences, Wednesday we have life sciences, then Thursday is just a mixture of geography, maths, lit, accounting, but that's for like mostly matrics. So make sure you catch us again, guys, if you do those subjects live from 4 for you grade 10s. Thank you for tuning in, and from us for the first show, it is a goodbye, and we'll see you again.
Answer to that. Let's get cracking with today's lesson. And guys, what I want to do is just remind you of a few terminologies that you have already come across. So most of you have been doing this at school already, so it might seem quite familiar to you. I hope so. But let's go over some of those terms. Firstly, we look at what is the meaning of a monomial. Monomial. Mono is the big clue there. Okay. That is an algebraic expression with just one term. So mono is single. So for example, an expression like x or just 7. So just a single term. So x, 7, y, anything that's just a single term all by itself, we call that a monomial. All right? A binomial, bi should be your clue there. Bi, think of like a bicycle, 2 wheels. So an algebraic expression with two terms. That's what we call a binomial, so something like x plus y, all right, or a plus b, or a plus 7, and the list goes on and on and on. So an algebraic expression with just two terms is called a binomial. Guys, remember that terms, because I keep referring to terms, what are terms? When we're talking about terms,
What's up, Mindsetters? Welcome to it, your very first show of 2014. I'm just so excited, guys. I am Looney, and in studio with me is Natasha. Natasha, how are you doing?
Hi, I'm very well, Looney. Nice to see you in the new year and to be with these guys.
Yes, grade 10s, you are our fresh faces because last year you were in grade 9. So welcome to it, guys, your very first live show. Maths, we're doing maths today. Natasha, what's the topic for today?
Guys, today we're looking at algebraic expressions, and we're going to be looking at products and factorizing.
All right, you heard it, grade 10s. I hope you're excited as I am. It's been such a long time. I haven't been here since like November, so we're still getting the hang of things, but we're so excited to have you guys tuning in. Remember to hit us up on Twitter and Facebook at Learn Extra, and our website is learn.mindset.co.za. So make sure you check us out, guys, for your notes and your videos on that website. So I won't waste any more of your time. I'll take it straight back to Natasha.
Thank you. Okay, guys, well, it's great to be back in the new year, and I hope that you're all ready to learn. Grade 10s, welcome to the show. It's your first time here, and if you're in grade 11, I'm glad that you're already revising. So today, as I said, we're looking at algebraic expressions, we're looking at products and factors, and remember, guys, maths is all about building blocks. You need to set up this foundation now so that by the time you get to grade 12, this old stuff, the grade 10 stuff, that will seem so easy by the time you get there, but it's all important. So it might seem basic to you now, grade 11s, but remember, in grade 10, it was also a completely new section. So for you grade 10s who are seeing it the very, very first time, you've obviously done it a little bit at school. We hope that this year you're going to ace maths with us. All right, so we're looking at algebraic expressions, products and factors. And as I said, we're discussing both factorizing and products in this lesson. However, what I first want to show you, and I understand it's also in the notes, as Looney will tell you just now, the challenge question. So by the end of this lesson, you will all be able to do this question. But I want to see now, at the beginning of the lesson, how many of you can do this. So try this. It's on the website. It's on the notes as well. Have a look and see if you can factorize this rather scary-looking expression. But I promise by the end of the lesson, it's not going to look so scary. Try and factorize x squared times x minus 2 plus 7 times 2 minus x times x minus 10 times 2 minus x. I'd love to see if any of you can get the right. We are talking about algebraic expressions that are separated by plus or minus signs. Okay. A trinomial, that's an algebraic expression with three terms. So think of a tricycle, 3 wheels. Similarly, an algebraic expression has, with 3 terms, is called a trinomial. So if I look at something like x plus y plus z, that is an example of a trinomial. It's something that you've got to get very, very familiar with, because later on, and by the time you're completely done with factorizing, you're going to understand how to factorize trinomials. So it is something that you need to be very, very familiar with. It's a term you're going to use often through the rest of grade 10, and then certainly all the way up to grade 12. Okay. Let's get started with products. That's our first topic. And what I want to do is just remind you about a little something. Okay, so if I take, for example, something like 6, all right, I know, and yes, this does have something to do with products. So, for example, if I have 2 in brackets 3 is equal to 6, okay, then I can say that the factors of 6 are, what is it made up of? The 2 multiples. The factors of the 6 are 2 and 3. Okay, now very similarly, and that's why I'm bringing this up at this point, and we're going to go into factorizing in a lot more detail. But if you understand this basic concept, remember when you're talking about algebraic expressions and we start dealing with letters, it can become quite confusing. But if you just remember that the letters are just a placeholder for numbers. So if I've got X's and Y's and A's and B's, it's really just a placeholder for a number. So it all represents numbers. So if we take things back to explaining to how it relates to a number, it becomes a little bit easier to understand. So 2 times 3, those are the multiples of 6. Okay? Sorry, those are the factors of 6. If we multiply 2 by 3, we get 6. So therefore, the factors of 6 are 2 and 3. All right, so the product 2 and 3 gives us 6. Distributive law works very similarly.